solve that. And after a while, you'll realize that you can do a bit more difficult stuff and a bit more and a bit more. And in 10 years, you'll get wherever you want to, basically.
Maybe also, if I can just pick on that, if you have a book which talks about analytical solutions for mechanical problems, just use a simple analytical example and try to model that within a FEA tool.
Yeah.
And then compare
that
them.
would be cool.
And because then you also get the feeling that you always have to make your hand calculations, right? So you get
Yes.
a feeling of, is the FEA result to be trusted or not? Because
My take on this, that's a very good point, Manuel. My take on this is that what I don't like about those analytical problems is that they are usually extremely theoretical. They don't often have relation to the real world work in some sense, right? I did like hundreds upon hundreds of different analytical examples in my life, mostly during university years when I was learning that. But most of them are useless now because I know that reality is so much more complex than those analytical examples that it's tricky. But it's true if I would like to firstly get a feel that it even works. Doing an analytical example and proving to myself that FEA gives the same answer gives me like a feeling that FEA works. And then I would go a step further, assuming that you are training at university to do like an engineering job of some sort, at least part of the projects will be design something. So when you know and you are fairly certain that you can design something safely and it's simple, try to calculate that in FEA. Because you can design it, you know what will work, and you can build your model and see how it behaves, if it works, what is different, and you can ask around, and you can go to a lecturer, for instance, or like write to the blogger or whatever, and say, hey, like I did the hand calculations of this is the outcome, and I did FEA, and it looks so weird. What went wrong? And you kind of like, it's a completely different question than how do I calculate a cantilever? Like, because the proper answer is quickly and correctly. That's how you're supposed to do it, right?
You get also a feeling for, in this case, model detail and where it's necessary and where it is not necessary. So also the difference between element types and stuff like that. So that's what we were doing at university at the lectures, to just try things out, model something in 3D, in 2D, in 1D, the same problem, and see the different outcomes. And,
that's a very good point.
I was so surprised that you could have, with less elements, you could have a better